Well, hello everybody. In this video, it's a quickie. This is about 5 minutes on the things I expect you to be able to do on your graphing calculator. Things that I assume coming in that you know how to do. Let's take a look at a particular function. Let's take a look at x cubed minus 4x squared minus 4x plus 16. Let's say I want to look at this function, and so I plug it into my y1 and this happens. And I say, well, I can see some things. I can see the three roots. I know that there are three roots. And I can see where the thing bottoms out. That's called a local minimum. But I can't see the local max. There's supposed to be a local max, and I can't see it. Well, perhaps that's because the y-intercept is 16. So I take a look at my window and I say, maybe my y's don't go high enough. Maybe my y's ought to go to 20. And oh look, there's the relative max. There's the local max, the place where the function tops out in that little interval. So now that I know how cubics work, I've got my max, I've got my min, I've got three roots, I have all the pieces I'm supposed to have. There are things I assume that you can do with your calculator. I assume that you can find those roots. I assume that you can use your calculator to find those roots. For me, since I'm working off of the TI Inspire for the computer, I can just say I want to find a 0 and go boom, boom, and the calculator gives it to me. For you, you probably enter the calc menu, that second calc, and then you find a 0, and then you shimmy to the left, and then you shimmy to the right, and the calculator tells you where the root is. Similarly, you can find the coordinates of that maximum. For me, I just find maximum and shimmy to the left, shimmy to the right, and I get where the coordinates of that maximum are. For you, it's probably second calc, bring the spider to the left, bring the spider to the right, and the calculator will tell you where that maximum is. I assume that you know how to find a root and how to find a max or a min. So that if you ask me on test day, how do I find this max, how do I find this root, I cannot tell you that. You've got to know how to do that coming in. So if you have issues with that, we should have a conversation. Okay. Other things we should talk about. Oh, you should definitely know. Oh, let's do this. You should know how to find those intersection points. If you graph two things, graph both things, see where they cross, see where they cross. You should know how to find an intersection of two curves. Normally that's second calc, find an intersection, and then you pick the first curve and the second curve and the approximate place where they cross, and the calculator tells you where the curves intersect. You have to know how to do that. Okay, so let's take a look at one other thing. You have to know when you have too much on your screen. You have to know that. Oh, maybe it's because I didn't use the standard viewing window. Oh, maybe it's because I didn't use the standard viewing window. Nope, still a problem. Well, what's the problem? The problem is that the period of that graph is 2 pi over 60. That's like 0.1. That's really small. So if I want to see just one cycle, I can go from 0 to 2 pi over 60. Now I've got one cycle. Now I've got one cycle. I've got something that I can look at that's better to look at than this. Hey, one other quick point, because our time is almost up. One other quick point. Consider the following. Bill Nye the Science Guy. Just because something looks like x squared does not mean it is x squared. There are times when I will show you a graph and you'll say, I know what that is. But if I don't tell you it's x squared, you don't know that it's x squared. And if you start doing calculus thinking that it's x squared, you might find yourself in a heap of trouble. It is also somewhat interesting to note that if instead of over 50, I just do that, that graph is a mess. That graph is a mess. Just something to think about. Okay, so you've got to know what you have on your screen and how to use what you have on your screen, and that's all I need to say. Okay, our 6 minutes are about done. Glad to have done it. See you soon.